You knew this was coming. Memory diagrams with references. How do references affect the memory diagram? And it's actually quite dramatic because remember, references store an address so that we can directly access that value at that location. So remember also that an address in computers is a bunch of hexadecimal. Instead of worrying about that, all we do is we have a small circle to indicate the value of the address, and then we use an arrow of that circle to point to that location and that address. So the code that you're going to see next is, well, I'm going to shrink this down a little bit though, but we got a lot of things going on in this code here. So we have me, Ray, Do, let's say, and then the main, of course. So you know which one we're going to start off from, but I'll get to that here in a minute. But I want you to notice right off the bat is which items, as we're passing values in, what are the parameters? What type of parameters are they? Are they copy by value, or are they pass by reference? And also we have to worry about the local variables inside as well. So there's a lot going on here. And as you can tell, I've highlighted the one that's going to have the pass by reference. The rest of them are pass by copy. These are all things that we need to worry about as we go through here. So what you may want to do as I step and go through each part of this, you may want to stop the video, just kind of recollect, see what I've got in the memory diagram, see if it matches up, and then go from there. So let's get started. So the code that you see right here is exactly the same as what I had before, just organized a little bit differently, but I still have the main at the very, very bottom. Even though it's at the bottom, you know, that's what we'll start off with first and then go from there. The other part is obviously we got an empty stack frame here for now, but that's going to change as soon as we start to call the main function, in which I'm going to do right now. So in main, you'll notice that I've got b in b equals do of 11. Now, I'm not totally done with all of the main, and that's why you see right here we're going to have our stack. It's going to have a main, it's going to have the b, and then again, it's not going to be completely ready yet because we still need to call do, and I'm sure we got more to go from there. So it's going to be empty for now. So now that we're in do, we have a lot of things that we need to take care of. First is identify any parameters that we passed in and what type they are. Then we have to worry about local variables, and then we worry about some of the things we can't answer quite yet because we might need other help. And that's all in this one function, if you can believe that. So first, we're worried about our first parameter, which is w. And that is going to be a copy of the 11 that we were passed in. So you'll see over here our 11 is going to be right here with our w. Then we're given a value for k equals 2, and you saw that over here. And then we're going to have our q be 3 plus the w, which is that 14 that you see right here. And z, well, we don't know what to exactly do with z quite yet, because z, frankly, there it is. We're going to have z, but we need another call to the re function. So we're not done with our do function. We've got to call one more function. Then we have a couple of couts and then display. By the way, you'll also notice our output. This particular one happens to be this k first. Now, I know you see another one. You probably know, uh-oh, k is going to change, and you're probably right. But we'll see. We'll see. So here's k. That's the original output that we have right here. Now we're going to go ahead and jump to re. So again, we're not totally done do. So do is going to be sitting there as we add our next call. So now we move on to re, since it was called from here in do. Now with re, it was given two values, k and q. Now those two values are right here. K is equal to 2 and q is equal to 14. So, but notice as I'm past those physically up into re, it's going to be s is 2 and p is going to be 14. Now, by the way, notice it says we have the exact address of the value of s. So you'll notice that's represented here with that squiggly line, is that we have the direct access to that value of s, which was 2. Now, why is it changed? Because, frankly, the next line down, in re. So because we have direct access to it, we went ahead and changed it. So that's why you see this being crossed out and sent to 12. Now, here's the other part, though. I didn't do anything with p yet. But we also got now a new function that we have to worry about, a new function call, and that's me of s times p, and we'll see what me does here in a second. But we're going to return that value that this function really ends up being. So you're going to see return a value back to do. You'll see an arrow end up right here with the value that we need to as soon as we get done with me. So as we're about to move on to me, we're going to go ahead and pass in the 12 and then times the value of p, which is 14, which is right over my shoulder there, which I believe is 168. So now we're going to move that 168 up into me, just like we have right here. We're going to have j is equal to 168, which is right over my shoulder right there. And then our I equal to 5. Both of those are listed right over my shoulder. And then we're going to return. We actually don't have another call. Yay! This function is going to return the modulus of 168 modulus 5. We're divided by 5. What's the remainder? It gives us 3. So you're going to see the 3 that I'm talking about right here. And this is because of the return that's being highlighted as well. So that return finally comes back to re, and then we're going to return that 3 from re back into do, which was the original one that called re. Now notice me finally is going to die off the vine, and re is going to finally die off the vine here in a second as well. But before we do that, we have our 3 being returned and being sent into z. So z is going to have an update here in a second. And there it is right there. And then we go ahead to our next one, print out k. K, remember, was changed from s. So again, you see how it's connected here with our s. And that is 12. We no longer need s anymore because that was originally from that function in re. We go ahead and display k, that's our 12. And then we finally return z plus w. So that z is 3, w is 11, that equals 14 obviously. So when we finally get back to main and we've done all of this do 11, finally that's going to be crossed out, equal 14. Int b is going to be 14, we display our 14, and we're done. A lot going on in that example, so just a heads up on that. A lot going on, but hopefully you understand what's going on here in the overall tree, because really I think I'm blocking more of the way of it, but that's really what's helping us trace exactly what's going on behind the scenes.